Hello everyone, my name is Andran Ali, the Bazuka Prophet, and I'm right here on your screen. And today we are going to be talking about a very interesting video, which is a major topic in the field of biochemistry and also in chemistry. Now, and that topic is called carbohydrates, from the word carbon and hydrate. Now, do not forget that carbohydrates is a macromolecule, which is among the four macromolecules we have. Something about the protein, the lipids, and the nucleic acid. And do not forget that carbohydrate constitutes a major class of naturally occurring compounds. An example of carbohydrate we have, starting from the simplest, which is the monosaccharide. Talking about, we have sugar, we have glucose, we have glycogen, we have starch. They are well-known carbohydrate substances. Now, we should understand that in the olden days, carbohydrate was called an hydrate of carbon. And that is where the name carbohydrate comes in. Hydrates of carbon. And based on the heading, we should now understand that carbohydrates consist of three major elemental substances, which are the carbon, hydrogen, and what now? And oxygen. In which the two latter, talking about the hydrogen and oxygen, are in the ratio of 2:1, as in the case of water. And that the general molecular formula of carbohydrates is CX bracket H2O close bracket Y, whereby the X and Y can either be same or different. Same as in the case of glucose, which is C6H12O6, which can be written as C6 close bracket H2O then 6. Whereby in this case, the X is 6, the Y is also 6. Now, why the X and Y can be different, as in the case of disaccharide, which is disaccharide, that we talk about sucrose, which is C12H22O11, which can be written as C12 bracket H2O11. Now we move quickly to understand that structurally, carbohydrates are polyfunctional compounds. And when we have the word polyfunctional, it simply means that it consists of more than one functional group. And on that note, we can define carbohydrates as organic compounds which consist of a polyhydroxy ketones or a polyhydroxyaldehyde, which, as we have here on the board, they are polyhydroxyaldehyde or polyhydroxy ketones, or compounds which are converted to this upon hydrolysis. Then we move swiftly to a very important area, talking about the classification of carbohydrates. How do we classify carbohydrates? Now, we should understand that basically some tests have different ways in which they can classify carbohydrates. And in my textbooks that was written by me in the field of biochemistry and also in chemistry, there is so much that is being revealed in my tests. But in this video, I'm trying to do a preview, a summary, so that when we enter the reactions of carbohydrates, you can flow in the pace. Now, carbohydrates are divided into three major classes. So depending upon whether or not they undergo hydrolysis, and if they do, on the number of products that is formed. And on that very note, We have the first one, which we call the monosaccharides. Number 2, the oligosaccharides. Number 3, the polysaccharides. Now, from the word mono simply means one. Saccharides, which is the other name of carbohydrate, which is sugar. They are polyhydroxyaldehyde or polyhydroxy ketone, which cannot be hydrolyzed upon hydrolysis. Why? Remember, take note that the monomeric units of carbohydrates, which is a giant or a macromolecule, is the monosaccharides. Are you with me now? Now we move ahead. Now, that we have said that, for example, if I'm having glucose, which is a monosaccharide, upon hydrolysis, there will be no reaction. Why? Because it cannot be broken down further. Why? It is the simplest. And the number of carbon in monosaccharide ranges from 3 carbon to 9 carbon. And furthermore, monosaccharides can be divided into 2 based on their functional group. Talking about the aldoses, and talking about what now? The ketoses. Now, we should not forget that most monosaccharides or most carbohydrates, their suffix always end in OSE. Talking about glucose, fructose, sucrose, idose, talose, arabinose, raffinose. So many examples. He said they end in OSE, which is the end in OSE. But there are few of them, not all of them. Remember, not all sugar ends in OSE. Example is starch. Starch is a sugar, but does not end in OSE. Chitin is a sugar, but does not end in OSE. Now, we have aldoses and ketoses. And on that note, we should understand that a 3-carbon sugar is called a triosis. A 4-carbon sugar is called a tetrosis. A 5-carbon sugar is called a pentosis. 6-carbon hexosis. 7-carbon heptosis. 8-carbon autosis, and 9-carbon nodosis. Now, again, we should understand some basic points under this feed. And what the point? That if among these monosaccharides, the most abundant, talking about the 3-carbon, 4-carbon, 5-carbon, 6-carbon, the most abundant is the 6-carbon sugar. Talking about the hexosis. They are wide range of function are too numerous. They are the most abundant in a living cell, in a living organism. Are you with me now? Now we'll continue. Now, furthermore again, we can also as well know that if I am having a 3-carbon that has the aldehyde functional group, it will be called an aldotriose. If I'm also having a 4-carbon carrying an aldehyde functional group, like we call an aldotetrosis. What if that same sugar or that monosaccharide has 3 carbon and contain a ketone functional group? It will be called what now? A ketotriose. Now, there is more under monosaccharide for us to dive into. But for this video, we will just talk about briefly on it. But in our next series of videos, we will dwell more on them. So we move ahead quickly. Number 2 is what we call the oligosaccharide. Now, from the word oligo, it means few. And we have said that oligosaccharide, they are carbohydrates which upon hydrolysis we yield the monomeric units that formed it. And the number of sugar, take note, the number of sugar or the number of monomers in oligosaccharide range from 2 carbon to 9 carbon in my test. Other tests can have different view. Now we continue. That oligosaccharide can be divided into two or more. Just like we have for 2 carbon is called disaccharide. It's like 2 sugars. It's called a disaccharide, in which upon hydrolysis they yield their monomer or they yield their monosaccharide molecules that formed it. And a very good example is talking about the sucrose, the fructose, sucrose, we have the maltose, and we have the lactose. Now we should not forget that sucrose upon hydrolysis we yield the monomers, talking about the glucose and the fructose. These are monosaccharide. Glucose is an aldohexose. It's an aldohexose. Aldehyde, hexose, 6 carbon. Fructose is a ketohexose. Right? It contains the ketone functional group. Maltose, upon hydrolysis, we yield 2 molecules of glucose. Lactose, we upon hydrolysis yield galactose and glucose. Are you with me now? They will then move to what we call the trisaccharides, which upon hydrolysis we yield their various monosaccharide units. A very good example is we have raffinose. We have raffinose. We have stachyose. We have raffinose. We have raffinose is a trisaccharide, while stachyose is a tetrasaccharide. In the case of raffinose, we are having glucose, we are having fructose, we are having galactose. All these are monosaccharides. We can also have pentasaccharides up to the 9 carbon, the 9 monomeric sugars that formed it. Now we move to the number 3. We talk about the polysaccharide. From the word poly means many, and I said there that polysaccharide are carbohydrates which have high molecular weight, and upon hydrolysis we yield many monomers that form many, range up to about 100,000. So many. So their molecular weight is very, very high. Talking about the starch, talking about the glycogen, talking about the chitin, the cellulose. We should not forget that starch and glycogen are the storage carbohydrates that is found in plant and animal respectively. While the cellulose and chitin are structural polysaccharides. Cellulose is found in plants and chitin is found, alright. Okay, so we have said that polysaccharides are carbohydrates with high molecular weights, and we talked about the starch, the starch, the cellulose, as the case may be. Then we move ahead quickly. So that carbohydrates may also be classified as either as a reducing sugar or a non-reducing sugar. Do not forget, either a reducing sugar or a non-reducing sugar. But before we talk about reducing sugar and non-reducing sugar, I should as well also say to you that we have 2 types of carbohydrates. Talking about simple carbohydrates and complex carbohydrates. We can also say complex carbohydrates or non-sugars. Now, what are simple carbohydrates? They are carbohydrates that are crystalline in nature. they are soluble in water, and they have a sweet taste, and they include all monosaccharides and disaccharides excepting sucrose, and that's monosaccharides and disaccharides majorly. While in the case of complex sugar, they are the opposite of, simple sugars. Talking about one, that they are amorphous in nature, they are tasteless, and they do not dissolve in water. An example, of course, you are aware, example include the polysaccharides. They will then move swiftly to the reducing sugar and non reducing sugar. Now, we have found that reducing sugars have the ability, take note, to reduce failing solution and Tolley's reagent. And we have said that a very good example is all monosaccharides and disaccharide excepting sucrose. Please take note, meaning that sucrose is a disaccharide but a non-reducing sugar. Why? Because a non-reducing sugar does not have or do not have the ability to reduce these two chemical tests. Talking about the failing solution and the Tolley's what now? Reagent. Now in our next video, we'll be talking about deeply on some major areas in carbohydrates, and most especially the reactions of carbohydrates. But now, God bless you. Please do well to subscribe to my channel. You can like and share, and you can also get my test by taking down my number. Which is 09081053321. My WhatsApp line. You can send in your messages and all. God bless you.